thing I do when I read a question is make sure that I in some way denote to myself what it is that I'm solving for, because sometimes you're solving for more than one thing. And for me, when I start solving a problem, typically once I get an answer, I call myself done and move on to the next problem. Whereas if I needed to actually find two things in that question, now I've just missed something. So for number one, it says that we need to find the area of a rectangle. So then I might draw myself a picture, since they didn't give us a picture, with a base of 12 and a height of 5. Our area formula, we can look up on the area sheet, says length times width or base times height. It doesn't matter what we call those things, but we're multiplying the two sides to find the area of a rectangle. So in this problem, that would be 12 times 5, which is 60. And then units will be expected if there are units given in the problem. So in this problem, it says that we're multiplying 12 centimeters by 5 centimeters. So what does that give us? Centimeters squared. Area is in square units because we're multiplying centimeters times centimeters. When we multiply something by itself, that's squaring it. So your area will always be square units, whether it's feet or meters or miles or centimeters or inches or whatever it happens to be. It will always be squared units for area. The second question says find the base of a rectangle again with a height of 8. And this time I know the area is 120. So using that same formula from the last question, we can plug in what we know. We know that area, or A, is 120. We do not know B, but we know H is 8. So how would I solve for B? Divide by 8. And 120 divided by 8 would give us 15. And then what kind of a unit will we have there? Meters. Since we had meters squared and meters, we're going to have meters for a base. Anything that could be measured with a ruler, so like a length, a height, those type of things I could measure with a ruler or a meter stick or a yardstick. Plain unit, just a plain, if it's something that I could measure with a ruler. So that base is going to be 15 meters. So this is one of those questions where we're required to do two things. So we need to make sure when we find our first answer, we don't say we're done, but that we find both of the things we need to find. Of a rectangle, this time with a and a perimeter of 42. I'm given that perimeter is equal to 42. And we can draw our picture of our rectangle. Has base of 16. What does perimeter mean? It's the length all around the edges. So what would perimeter be in this question? It's 42, but what is 42? 16, and another 16 because of the top. And what about those heights?
5.
They will be, yes, but you're jumping ahead. How would I put that into the equation? It's not h squared, it's 2 h's. We're not squaring them. Squaring is when we multiply, we're adding an h plus an h. So that gives us 2 h's. So 16 plus 16 is 32, and if I subtract that 32 from both sides, I get 10 is equal to 2h, so h is 5. Okay, that was our first answer. We need a unit on that, 5 centimeters. We were also asked, though, to find area. Area is base times height. Now we know our base and height, so we can multiply those together. And what do we get? 80. And what unit would we want on that? centimeters squared. Area will always be square units because it's multiplying a length times a length. Questions on that? Number 4 is kind of a strange shape. We don't know what this shape is. It doesn't have any sort of special name, and we don't have a formula for it. So what could we do to calculate the area of that thing? Divide it into shapes that we can work with. So specifically, what shapes do we see a lot of here? Rectangles. And there are several different ways that you could divide this up. I chose to divide by cutting it straight across in those two spots, but you could also divide it by cutting up and down, right, those parts. You could do both of those things, and then you would have 5 different sections. It doesn't matter how, but somehow we need to turn this thing into rectangles. Then find the area of each of those rectangles. So for the top one, I have a height of 7. What about the width of that top one? 5. Why 5? Because there's 5 at the bottom, and since everything is nice and straight and symmetrical and even and right angles, that 5 is going to carry right on up. So that top one has an area of 35. 7 times 5. The middle one, we have a 6 over on the right. What about the middle part? 5. Now the left part, I probably should have been a little bit more specific in the directions, but if we assume that this is a symmetrical figure, how long would that other side be? 6, just like the right side. So that length all the way across there then is 17
Times 5.
with a height of 5. 17 times 5 gives an area of
75 or
85. So we got 85 for that middle one. Obviously, this is not to scale since the 6 is much bigger than the 5, but we'll just go with it. And then the bottom one. What do we have for the bottom one? 2 times 5 or 10. Now, what do I do with all those? Add them up. So 35 plus 85 plus 10 gives us 150. There were no units in this question, so you don't need to provide any units for your answer. So you could say 150 units squared, but you don't have to. 150 is fine. But do not write 150 squared. We're not squaring the number. We would be squaring the unit, like centimeters or meters, and since we don't have one of those, we don't need to include a squared. We do not want to square the number. Is it 130? Yeah. Okay. That's what I get for trying to add without a calculator. Questions on that, now that I have the right answer? All right, number 5. Number 5 moves on to triangles. Section 11.1 is all about rectangles. So that first group of problems in your homework is all going to be rectangle problems. So then number 5 asks for area of a triangle this time. What is our area of a triangle formula? Half times base times height. Because a triangle is half of a rectangle. If I cut a rectangle down its diagonal, I would have a triangle. So if a rectangle is base times height, then a triangle would be half of that. So if we plug in what we know here, we'd have 1/2, a base of 6, and a height of 4. So that gives me an area of 12. Unit, meters squared. Square unit.
Multiply 6 and 4 and then do half.
It doesn't matter what 6 times 4 gives 12. Or you could do the 6 times the 4 and get 24 and then take half of that as 12. Either way, it's the same thing.
Wait, but wouldn't you take half of 4?
No, not half of both of them because we're not doing a distributing here. Multiplying, we just multiply straight across every piece. Good question. The next one says area of a parallelogram. What is our area of a parallelogram formula? Base times height, or length times width, or whatever it happens to be. I'm going to show you where this one comes from, because if you can understand why a formula is what it is, it can make it easier to study and memorize. So a parallelogram looks like this. Height is always a perpendicular thing. So this would be our height. That would be our base. Because this is a parallelogram, the slants on both of those sides exactly match because they're parallel. So if I could take scissors then and cut off that little triangle, I could tape it over on the other side and it would fit exactly because those slants match. So if I cut it off and tape it to the other side, what shape is it now? A rectangle. So the area of a parallelogram is the same as an area of a rectangle. It's just base times height because we could turn that parallelogram into a rectangle. Okay? So a parallelogram's area is base times height. Just make sure that when you're doing height, height is vertical. It's all perpendicular to the slanty side. Area of a rhombus is the formula that I said on the sheet. You do not need to worry about memorizing. Diagonal 1 times diagonal 2. Okay. 1/2. I don't have it memorized either. 1/2 of diagonal 1, diagonal 2. So 1/2 of 10 times 5, since we're given the diagonals, which is 25. Unit? Meter squared. The next one wants us to find the area of an isosceles triangle. So we're given a little bit of extra information here about this, that it happens to be isosceles. So I'm going to draw myself a picture of that triangle then, with sides of 5, 5, and 8. So not quite to scale, but that's not important. Area of a triangle, what's the formula? Half times base times height. Problem. Heights are always straight up and down. They are not slanty, so 5 is not the height. The height would be what happens when I drop down the middle of this thing. When I drop down the middle, I'm going to hit out a right. It's going to cut up equally so that I have 4s on each side. So then if I focus on just part of this picture, I have a right triangle with a side of 5 and a side of 4, and I need to know the other side. How do I find that? Pythagorean theorem. 4 squared plus height squared equals 5 squared. That would give us 16. Subtract that out, gives us 9. So our height is 3. 3, 4, 5 is kind of a special triangle for us. Those numbers will come up a lot on math tests and on ACTs and standardized tests. We like to use the 3, 4, 5 triangle because the numbers are so nice and clean. So if you see a 4 and a 5 in a right triangle, we can know the other perpendicular side is 3, or any other. So now I know area is 1/2 of base. Which side is going to be the base? The bottom, the 8. Not necessarily the bottom because the way I drew it, because I put the numbers wherever I wanted to put them, but the base should always be perpendicular to the height. So since I drew that height down to the side of 8, that's why 8 is the base. And then the height is 3 we found. So we get what? 12. And there were no units in this question, so you don't need to give any in the answer then. So our answer is just 12. Questions on that? Okay, section 2 is about triangles and parallelograms and rhombuses. Section 3 will be about trapezoids. So these last few questions are about section 3 trapezoids. Find the area of a trapezoid. What is our area formula for trapezoid? 1/2 times the height times the sum of the two bases. In a trapezoid, the two base sides are different lengths. It doesn't matter which one is which.
Wait, that's B and then half.
It's 1/2 of h, the height, plus the two bases, which are called base 1 and base 2. A trapezoid would look something like this, maybe. We could have a straight side, we could have another slanty side, but we have two parallel sides and two non-parallel sides. So in this question, we're given the height is 7, and then we're given the bases of 12 and 8. And it doesn't matter which one is which, so don't worry about plugging those into the wrong spots. One of the bases is base 1, the other one is base 2. It doesn't matter which is which. Order of operations is important here. What do I do first to calculate this? Do what's in the parentheses. But since there's a longer way about it, it's not. The 20, 1/2 times 7 times 20 is 70. Okay. Question number 10 wants us to find base 2, or the second base. We're going to use that same area formula because we're still working with a trapezoid. This time we know the area is 12, it tells us at the end of the sentence. The height is 3, and the first base is 3, but we don't know the second base. So we plug in what we know in that equation, which leaves the second base being our unknown. So this time we do have an equation to solve. Several things we could do first. We could do some distributing first. We could multiply the 1/2 times the 3 first. I personally don't really like working with fractions. I like fractions. I think they're extremely useful things, but I don't really like working with them. So if I can get rid of them, I try to. So how do I get rid of that 1/2 in the front? Multiply by 2 for the equation. So that gives us 24 equals, and that multiplying by 2 just gets rid of the half. It doesn't change anything else in the equation. It just gets rid of that 1/2. The 2 undoes the half. Then again, it's yes, I wrote H. It should be a B. Thank you.
Where do you get the 2 from?
I multiplied by 2 to undo the 1/2. Then, two options of what I could do next. I could distribute the 3, make it 9 plus 3b, or I could get rid of the 3. How do I undo that 3? Divide by 3. So if I divide both sides by 3, that would give me 8 and 3 plus b. And so b is 5. That second base is 5. Questions on that one? needing to do some algebra to solve it out. All right, last, I have an isosceles trap. Length. Bases of 10 and 18, and I'm purposely going to put that 18 a little bit away from the side. Area of a trapezoid formula, whether it's isosceles or not, is all the same, and we have that formula back in question 9. For that formula, I need the height, not the slanty height, the straight up and down height. So if I draw that in here, it would cut off some triangles. On the bottom side of this trapezoid, how long is the middle chunk? Why? Has to match the top. We're dropping perpendicular heights, so we're really making a rectangle there in the middle. Now, since this thing is isosceles, everything gets broken up nice and symmetrically. So how big are each of those other bottom pieces? 4s, so that all together I would have 18 total. So I used up 10 in the middle, so I've got 8 left over, and I'm going to divide that up equally, so each of those little side pieces is 4. So that gives me a triangle now that has a 5 on the hypotenuse, a 4 on the bottom, and I want to know the height. That looks a whole lot like the other theorem. Doing this Pythagorean theorem already in the green there, it turned out into being exactly the same triangle we had earlier. But we would find it with the Pythagorean theorem. 4 squared plus h squared equals 5 squared. So then we're ready to do our formula. Area is 1/2 times height we found was 3 times the sum of the bases, and it doesn't matter which way you do it, 10 plus 18 or 18 plus 10, because either way, that gives 28. And 1/2 times 3 times 28 gives what? 42. There's no units in this question, so we don't need to worry about units for our answer. Okay, so tonight's homework is the 11-1, 11-2, and 11-3 assignments here, which again looks like a lot because it lists all the questions. It doesn't say any multiples of 3 or anything, but it's 22 questions, so it's not really any longer than normal assignments are for us.